Hello everyone, this is Xiaowen and I'm from Hong Kong University of Science Technology and under the supervision of Professor Jack Cheng. And today I will present our work regarding on the VLM and knowledge graph generation for the construction safety monitoring. As we all know that the construction sector is very hardest fatal accident that even Europe, even 2022, 23% of all 40 accidents happened in the construction sector. And similar situations happen also in the US and all around the world. So, but for the current safety management method is still have some limitations. For example, for the computer vision method, it will lack of the semantic understanding and flexibility. Each task needs a separate model training, and we need to do a lot of training work and data annotation work. But also for the VLM that is newly provide some potential, it's still lack of domain knowledge that may cause some hallucination or the error judgment because they are lacking of the safety context. So we want to inject the domain knowledge into the VLM to help improve the accuracy of the VLM. We consider to use the retrieval augmented generation, which is nowadays a popular one. But for the typical retrieval augmented generation, we need to do the text trunking before we embedded the entire safety handbook into the system. So if we want to trunk the text, we need to consider about the size of the trunking. Even the larger or the smaller trunk will cause the information confusion to the VLM to conduct the correct judgment. So if we want to structuring our regulation test into the knowledge graph, which is a more structured way, it remains a highly manual and also resource-intensive way. So we need the expert to extract the ontology and to do the a rule-by-rule breakdown of each regulation. So for our method, we have potential to do the automatic regulation parsing, which can automatically transfer those unstructured regulation tests into a structured machine-readable way for the VLM to understand and explain. And we can also, and this method can maintain the legal context instead of the fixed length trunking method. And we can also enable the duplicated similarity regulation into the network dynamically. So the problem for this work is that how can VLM to conduct a visual analysis output regulatory ready set descriptions, and also how to integrate the LLM into the automatically build the knowledge graph. So for our method, we have two modules to do the work. We have first the visual analysis module to transfer the site photo into the text description. And then we have the knowledge graph generator and also the retrieval module to do the rule retrieval and mapping to the corresponding corresponding site photo. Here is the detailed information. We first have the visual analyzer to transfer the site photo, and then we use a domain knowledge construction to automatically parsing the safety regulation into the knowledge graph. And then we have the semantic retrieval to input those regulations into the VLM to do the further compliance analysis. And here is the way how we design the VLM to do the information extraction from the site image. We use the 4M1E schema to do the extraction. We let the VLM to focus on the man, machine, method, and environment instead of letting it to describe the unboundary details of the construction site image, which will cause to the information over fusion. And then for the retrieval part, as we mentioned before, the improper trunking will lead to the knowledge confusion. So we want to, so the regulation handbook is a structured documentation. So we like to keep the context awareness about the to do the trunking. We want to trunk it according to the structure of the regulation handbook itself. So we let the LLM to do the rule extraction from the handbook. here is our prompt design. We first define our rules, and then we use some chain of thought sequencing to guide the LLM to do the extraction, and then we set some navigative constraints that the LLM to do the deduplication of the similar meaning rules, and then we will let the LLM to output the JSON LD format to do the machine readability of the regulations. And here is our structure of the knowledge graph design. We will first have the conceptual layer and the data layer. The conceptual layer this is where we conduct the retrieval. We will first have the rule nodes, which contain the deduplicated rules from different handbooks and also from different sections. And we'll have actions and hazards, those kind of things that we use to do the retrieval. And then we will have the data layer, which contain the original regulation tests, which including the clause, the section node, and also the handbook node. And here is the detailed design of our knowledge graph structure and what kind of relationship we have. And here is the method how we do the retrieval. We first calculate the cosine similarity between the user query vector and also the rule vector, and then we select the top k initial rule node, and then we trace back from those rule nodes to the foundation layer clauses, that is the clause node in the data layer. And here is our experimental design. We use the 3 handbooks from Hong Kong, and then we conduct our experiments primarily on the 60 images from the Hong Kong real reconstruction site instead of the the internet photos. And we use the ChromaDB Q1 embedding model, DeepSeek V3, and also the InterVal 3.5 as our model to do the information retrieval and also the knowledge graph generation. And we compare our precision, recall, and also the F1 score as our matrix. And here you can see the LLM can reliably transform the unstructured regulation into the precise and also the duplicated rule node. As you can see that the overall precision and also the recall, the F1 score is over 97% of the accuracy. And here is the visualization of our LLM constructed knowledge graph. As you can see, as you can see that for different categories, it's grouped into the adjunctive rules, and also here are some linkage between different categories. That is the cross node sections, and you can see here the rules. This one, the worker must wear full body safety harness. This appears in 2 separate nodes, 2 separate clauses, but in our knowledge graph, it have been condensed, deduplicated into 1 rule node and linked back to the 2 separate clauses to ensure the conciseness of the overall knowledge graph. And here is the result of how our VLM extracts the information from the constraint side photo. Guided by our 4M1 schema, as you can see that the VLM can extract exactly what are the working platform used in this picture, and then due to this information provided, the overall system can extract those kind of power electric working platform and also the mobile working platform regulations, which are all related to this image. And here is a comparison of our knowledge graph retrieval and also the traditional, like the fixed trunk retrieval accuracy. As the traditional fixed trunk RAG will cause some confusion regarding on the provided knowledge. So our method have a 12% of improvement in the retrieval accuracy. And to summarize, our method, we're using a 4M1 framework to do the structure analysis of the VLM to do the information extraction from the constraint side photo, and we use an automatic pipeline for the guide the LLM to do the knowledge graph construction, and the semantic retrieval has been increased from 12% by our method. But our methods still have some limitations. For example, we only focus on the Hong Kong regulation now, and our data set scale is relatively small. So in our future directions, we will expand our regulations into the international standard, and also we would like to integrate our causal reasoning for the automatic risk prediction. And that's all for today. And thank you for your listening.
Thank you very much. Great. Okay, any